Alright, this is a simple example of variation. In this problem, what we're going to be doing is varying directly, which is probably the simplistic um, version of variation. So here we have the price of gas varies directly as the square of the price of bread. I'm just making this up. But there probably is some kind of relationship between the cost of gas and the cost of bread someplace. As the square of the price of bread. When a loaf of bread costs $2.25, gas costs $3.70 per gallon. And then you have the question part. So again, these variation problems are always two parts. The information part, which is this one without the question, and the question part, which is answering a little bit further. The information part here from here to here is used to find k. Using direct variation, we're looking for the constant of variation. So that's going to be our part 1. So part 1 is always, for a variation problem, finding that constant of variation. So here, since the price of gas varies directly as the square of the price of bread, we're going to be looking at a direct variation. This is the general setup. And what I want to do is substitute in the words and the ideas into the formula. So here on the left is the price of gas. So I want Y to be represented by gas. So I'll use G for that. And it varies directly, so that would be just the K, as the square of the price of the bread. So if this is the price of the bread, B, I have to make sure that I square it. So this becomes our formula for this problem. Alright, that's part of part 1, trying to get to that K. So the next part is actually use these numbers they gave us. When a loaf of bread costs $2.25, so here in the bread we're going to put $2.25. And don't forget to square it. The K we don't know yet. And then back up to the problem. The cost of gas was $3.70 per gallon. So over here we're going to get 3.70. So to solve for K, we're going to take the 370 and divide by 2.25 all squared. So let's see here, 3.70 divided by 2.25 all squared. So about 0.731 if I go 3 decimal places. So K is equal to 0.731. Okay, so that gives us part 1, and then we can start working on part 2. So part 2, oops, I didn't switch over. There it goes. Part 2 is actually answering the question, or questions sometimes. So the first thing of part 2 is you start off with the formula with the K involved. So we're going to have G is equal to, K is now always going to be 0.731, no matter how many questions are going to be asked about this relationship. And then the rest of it is that B squared, the price of the bread squared. And then we can answer the second part of the problem. How much will the bread cost when the gas costs $4.10 per gallon? So here we know the cost of the gas, so this is going to be $4.10. The K is 0.731. And what we're looking for is, what is the price of bread going to be? Alright, so all we need to do is solve for B. The first step would be to take the 4.10 divided by the 0.0731. That gives you 56.1. So this would be 56.1 is equal to B squared. And to get rid of the square, we're going to square root both sides. So we'll square root that 56.1. And B is going to be approximately, we're rounding here, the price of bread will be about $7.49 a loaf. I really hope that's not the true relationship between bread and gas. But that's how you solve a varying directly type problem. Alright, here's another variation problem. This one is a professor found that on average um, a student's grade vary inversely as the square root of the number of absences. So in other words, since this is varying inversely, the more absences a student has, the lower their grade would be. It seems logical. So he found a student on average that missed 3 classes would have about an average of an 87 in the class. What would the average be for a student that missed 6 classes? And then a second question, what would be the maximum number of classes that could be missed? And a student would still get a grade of about a 70. Alright, so let's set this up. This one says varies inversely up here. Varied inversely. So we're going to use the standard equation y equals k over x. Now again, I like putting in letters that make sense to the problem. So the student's average over here, we can consider that grade, so I'll call it big G. K is just k, and then x is absences, so I'm just going to put a big A over here. And I didn't want to use A and A for average and absences, so G represents grade, A represents absences. Alright, so part 1, we always solve for, k. So plug in what we know from the first part. So the first part is here. A student can miss 3 classes and they would have a grade of an 87. It gives us the 2 pieces of information, the G and the A. So the grade they would have is an 87. Oops, and I screwed up the formula already. This says up here varies inversely as the square root of the number of absences. So this is missing a square root. Alright. Common mistake. So you get k over the square root of the number of absences. Well, in this case, he missed 3 classes. Alright, so to solve for k, we're going to multiply both sides by the square root of 3 and get 87 square roots of 3, and then use a calculator to figure out what that is equal to. So let's see here, 87 square roots of 3, 150.7. I'll go 1 decimal place. So k is going to equal 150.7. Okay, now for part 2. Part 2 of the problem is going to be setting up our formula with k involved. So k is 150.7 and divided by the square root of the absences. And the second part of the problem, it says what would be the average of a student that missed 6 classes. So what we know here is the number of absences, and what we're looking for is the grade. So the grade is going to equal 150.7 divided by the square root of the number of absences, in this case 6. Alright, so take that and divide by the square root of 6, and you get 61.5. So we would expect a student to get a 61.5 average in the class if they've missed 6 classes. Alright, last part. Red sounds good. So in this, it actually has a part 3, but it's basically the same as part 2. We're going to use the formula set up and plug in what we know. So we get G equals 150.7 over the square root of A. Alright, so for this part, we have here what is the maximum number of classes that can be missed. Oops. And still get a grade of a 70. Alright, So the grade, what we're looking for is a 70, so that goes into the G. This stays the same, 150.7, and over the square root of A. So what we're trying to solve for here is this A. One neat trick we can pull is create a proportion out of this. And proportions, the diagonals don't matter what order they're in. So I'm going to switch the 70 and the square root of A. So we get the square root of A is equal to 150.7 over 70. And then to solve this, we're just going to square both sides. So in my calculator, I'll figure out what 150.7 is divided by 70, and then take that answer and square it. So we get about 4.63. Now, to answer the question, this teacher's really stickler. You're either absent or you're there. So this 0.63 is not going to help us, because if you miss 4 classes, you'll get a grade a little bit above a 70. But if you miss a little bit more than 4 classes, your grade's going to get, 4.63 classes, your grade's going to go lower than a 70. And this teacher's not going to allow you to miss 0.63 of a class. So the answer to the question is the max is only 4 classes. Because once you miss 0.63, you're going to be missing 5 classes and your grade will go below a 70. So the answer to the question is just 4 classes. Here's an example of joint variation. So we're going to be doing something that varies jointly. So the max amount of force on a window during a hurricane varies jointly as the square of the velocity of the wind and the area of the window. A window that is 5 by 8 experiences a force of 200 pounds in a storm that produced 70 miles per hour winds. How much force will the window that's a little bit smaller experience in winds that are a little bit bigger? So just like any other variation type problem, there are 2 parts to this. So part 1 is always going to be find the K. So we need to find K here, or the constant of variation. So this is a joint variation, so we can set it up as y equals kxz. Now this is the standard form. It is not the form that we're going to use though. So instead of y, k, and z, I'd like to associate it with the words that are in the problem. So here we have force, and this is what y is going to be, so I'll represent that with capital F. K is just K, it's just some kind of constant of variation. And then x and z, we have our own free choice. So 1 is the velocity. So if I let x be the velocity, it's the square of the velocity. And then over here we have the area of the window, so I'm just going to let that be represented by capital A. Alright, so part 1 is get your formula down and then go and plug in what they have. So we have a 5 foot by 8 foot window, so that's 40 square feet, so that's going to go in for A. Then we have the velocity of 70 miles per hour, so that's going to go in for V, and don't forget to square it. And here's K, and the force on this window is this 200 pounds. So here we can solve for K. It's going to be a really small number. We're going to have 200 divided by 70 squared times 40. Yeah, so K is a really small number in this case. K equals 0.00102. I'll go 5 decimal places. Alright, part 2, let's change colors here. Part 2 is solve the problem. So we're going to solve or answer the question. The first part was just a bunch of information to get to the K, but part 2 is actually going to be solving the problem. So I'm going to write the formula down, and everything stays the same in the formula, which is here. except for the k is actually now a number. So we got f equals k, 0.00102, and then we have our v squared times a. And we go to the second part of the problem, which is the question part of the problem, plug in what we know. So it says how much force? Well, that means we don't know what the force is, so we'll leave that as f. This isn't changing just yet. The velocity squared that this thing is going to be experiencing is 120 mile per hour winds. So this gets 120. And then A is the area of the window. Well, this window is a 3 by 4 or 12 square feet. So this would be 12. So let's see here. Times 120 squared times 12. So the force on the window, a little bit smaller, but a higher wind factor, velocity is 176.3 pounds. And you always associate the letters with their measurements. So here force is in pounds because the original force up here was also in pounds. And that's it. That's how you solve a variation problem, in this case, joint.